All right, you guys can see the title of this unit is called Matrices. What is a matrix? It's a list of numbers, all right, inside some brackets, all right? It's going to be organized into rows and columns, all right? These numbers are going to be placed inside brackets, arranged in rows and columns. So how do I get a matrix? Well, you can get a matrix from equations. So you guys can see in 1A, it wants us to create a matrix based on these three equations. All right, so it wants us to do a rows and columns of numbers inside a bracket based on these three equations. And you guys are going to see this is going to be pretty darn easy at first. So I start out with my brackets, then I'm going to put numbers in. How do I figure out what numbers to put in? It's the numbers in the actual equation. I never put X's and Y's or Z's. No variables inside your matrix. None. It's just the numbers out in front. So the first equation right here, 2x plus y plus 2z equals 2. Here's how I start building the matrix. My first number in the matrix, 2, because that's the number in front of the x. The number in front of the y is 1. So the next number in the matrix is 1. Third number in front of the z is 2. Now you come to the equal sign. And for the equal sign in a matrix, we put a vertical line down. That tells us there was an equal sign there. And then what it's equal to on the other side, 2. So see how we just came up with that? X, Y, Z, the equal sign, and then what it's equal to. And I'm going to do the same exact thing now for the next two equations. So I'm going to go 3, -5 for the Y, -1 for Z. Notice no variables in the matrix. Equals 4. So this is what a matrix is starting to look like. You guys start seeing the rows and columns that we're building. And then you put the third equation in. 1x, so I'll put a 1 here. So everything in the first column is all x's, right? Anything in the second column is all y's. So in this case, -2. Anything in the third column are the z's, -3. And then this one's equal to -6. So that's how I build a matrix given equations. Anything you want to ask before I kind of leave some stuff out when I get to part B? Any questions from you guys in class or at home building that? All right, next up for B. So I got my brackets. Let's fill it in with my rows and columns now. First equation, no big deal. That was just like in part A. 5, -2, -3. My vertical line for equals, and then, yep, 0. It's equal to 0. All right, now we get a little tricky. Not tricky, but something different. Now it just says x plus y equals 5. But what about the z? All right, well, for x and y, we can at least put 1 and 1. If there's a variable missing, we still got to fill out a number. We can't leave it blank. So if the variable is missing, we put a 0. Okay, there is no variable there. We put a 0, so there is no z there. Still equal to 5, though. And then from here, next one, now take a look. The y is missing. So I'll start out with 2, but since the y is missing, you're going to fill in a 0 for the y there. -3 for the z, and then 4 for the answer there. So that's what a 0 means in there, that the variable was missing. Anything from you guys? All good? It's not that bad, right? All right, let's go backwards now. I'll give you the matrix. You give me the 3 equations now. All right, so for 2A, I have the matrix there. Use x, y, and z as your variables, and tell me what my equations must have been. You see some zeros there. That means the variable isn't there for that equation. So equation 1, 5x. There is no y. There's a 0 there. So plus 3z equals negative 11. No x in the second one. Just y. Minus 4z equals 12. And then 7x plus 2y, no z here, equals 4. Whew. All good. Hopefully today shouldn't be difficult at all, I hope. All right, next. How do you tell me how big a matrix is? Because, I could have a couple numbers, I could have a ton of numbers. How can you tell me how big a matrix is? Well, how big it is, that's called the order. All right, so instead of just saying, hey guys, how big is this? I'm going to ask you, what's the order now? And the way you determine what the order is by the number of rows, okay, number of rows times the number of columns. That's how you always tell me how big a matrix is, or the order. How many rows it has. You always go rows first. Rows first, columns second. So look at and I know I already have the answer up here, but take a look at this matrix. Ready? Rows right here. Some kids always have a little trouble at first. Here are your rows. So there's 3 rows by, here are your columns up top. Okay, these are your columns. I know most of you know that already, but just in case. Those are your columns, and I have 4 columns. So I say the order of this matrix is 3 by 4. It is a 3 by 4 matrix. Rows first by columns second. Rows by columns. That's how I figure out the order, the size of a matrix. All right, I'm going to let you guys go on your own here for A, B, C, and D. See if you can tell me the order. What is the size of each of these 4 matrices? Row by column. Row by column. And I'll call on a couple of you guys. Might get tricky. C and D might get tricky on you, but I know you can handle it. All right, here we go. Let me know what you got. Part A. What's the size of that matrix? Part A, what's the size? Anna, what'd you have? What's the size of that matrix?
2 by 4.
Good job. That's a 2 by 4 matrix. 2 rows by 4 columns. Good job. All right, what about B? What's the order of B? Liz, what do you have? What's the order for B, Liz?
Is it 2 by 2?
You got it. 2 rows, 2 columns. All right, now we get a little tricky here. What about C now? What's the order for C? Liz, I just called on you. We'll do another one later on for you. Nick, what do you got? What's the order for C? No Nick today. All right, let's keep going then. I do want to hear from people, definitely. Not here either. Okay, Kian, what do you got?
1 by 4.
Good job. Hey, this is 1 row by 4 columns. 1 by 4. Good. And then the final one here, just 9 hanging out by itself. Colin, what do you think?
1 by 1.
That's it, 1 by 1. Good work, 1 by 1, it's possible. All right, you guys at home, okay? Name in a matrix, the order. All right, now the next thing I got to talk about is, like if I say, hey, -7 in this first matrix in part A, how can you tell me where its position is? All right, what position is -7 in that matrix? And we name it just by the same way we do the order, row by column, row then column. So for instance, if you take a look at my matrix A here, that's got 3, 0, -5, etc. If I'm asking for what's in spot 2, 3 like this, so matrix A, that's what the A is there for because that's what the name of the matrix is, A. What's in spot 2, 3? Again, row, column. Row and column. So if you look at row 2, column 3, where do those two intersect? In matrix A, they intersect at number 1 in that matrix. Number 1 is in that position. Row first, column second. Okay, so that's how I find a number's position in the matrix. Row first, column second. Hopefully I'm not going over this too fast. Everyone all right? Okay, try it on your own now. Well, actually, never mind. I'm going to do them with you. Okay, here's my next example on the next page. You got matrix D. Sorry, I couldn't fit the brackets around all of it. What is in spot D22? So the D stands for matrix D, which I gave you. What is in spot 22 right now? What number is in spot 2? 12, here we go. Dan, what number is in 22?
Wouldn't that be 4?
4. Row 2, column 2. There's a 4 there. Correct. All right, how about matrix D, 3, 1? What is in position 3, 1 for me? Shoo, Mason, what do you got? Position 3, 1.
-3.
What's the 3 means? Row 3,
Row.
first column.
Also 0.
0. Good. Row 3, column 1. I got a 0 there. And then what's in position 1, 1? This isn't bad, right? 1, 1. What do you got, Colin?
-1.
-1. Ready for that last one? 2, 3. 2, 3. Anybody see a problem?
It's not there.
It's not there. It doesn't exist, does it? Everyone see row 2 is there, but column 3 is not. So we're not going to put a 0 there because a 0 is a number and there's not a 0 there. So if it does not exist, which will happen to you, we say undefined. We say it's undefined if it does not exist. Okay, undefined if it does not exist. All right, and that's really all the new stuff I wanted to show you today. I don't want to end class right now. It's way too early. So what I have for you right now is a couple problems to try out on your own. Okay, so try these out on your own. I'll write the answers up as you keep working. So as you guys are finishing up, here's my matrices for A, B, and C. Take a look. The only thing I'd be concerned about is part C, the last row. Make sure you have 0, 0, 1 and not 0, 0, 2 in the last row of matrix C, because the number in front of Z is 1. So make sure you have 0, 0, 1. Take a look through, make sure your numbers are in the right spot. And then numbers 2 and 3. No variable if there's a 0 there. All right. Almost all the assignments, when we have assignment day like tomorrow, most of them are going to come from Delta Math this unit, except for the end of the unit. But we'll wait till we get there, because I thought that was going to be easier on you guys instead of, taking pictures, writing it on a Chromebook you don't want to write on, right? Just doing it in Delta Math is easier for you and me. So that's what we're going to start tomorrow. These same type of problems on Delta Math. All right, so I'll see you tomorrow for that. Have a good day, guys. Bless you.
9.
Have a good day, guys.
Mr. Carlino, I handed in like every single thing that like you need to the health office this morning.
Okay.
So I think, I don't really know like when I'm gonna like be cleared or whatever, like how I would know, but.
I'll probably get an email from them, or I can check with them too.
All right,
And I'll
thank you.
text you when you're all set, and we'll set up the time to get equipment.
All right, thank you.
Okay, thank you. All right, guys, let's start with the homework that you guys started. Some of you may or may not have finished on Fridays during the half day, the shortened class. Dealt with, let me pull it up here, dealt with, as you remember, not only how do I move a triangle on top of another or a quadrilateral, because that was the case in number 4, how do I move one on top of the other, but also explaining why they're congruent to each other using rotations, translations, and reflections. I will give you, you do have your test this week on Wednesday or Thursday. I will give you one of these. I'm going to call them, I know it's not statements, reasons, but I'll call them proofs, because that's what they are. You're proving triangles congruent. You'll have one of them on your test this week. So any issues putting one on top of each other, moving it on top, or explaining why they're congruent? Any issues we need to cover here on these 4 questions from the weekend? Okay, nothing at all. We're all good. All righty, you guys at home, go ahead and submit it. You guys here, I think I just put everybody on the assignment, so let me take you guys off.